Hello, and welcome to another daily Leetcode challenge. Let's begin our daily question. 1351, count negative numbers in a sorted matrix. So given an m by n matrix grid, which is sorted in non-increasing order, both row-wise and column-wise, so decreasing, return the number of negative numbers in a grid. So besides the very obvious approach where you just iterate through the all the elements in the matrix or in the 2D array and figure out how many negative numbers there are, there's clearly a way to do this faster because we could stumble on the first negative number, and given that this is a sorted array in a non-increasing order, right? In a non-increasing, so in a decreasing order, then the rest of the array is going to be negative. So we could cut down on that number of iterations. Initially, though, let's solve it the simple way. Negatives. It's going to be 0 for I in range len grid, for j in range len grid 0 if grid I and then j is less than 0, negatives plus 1, return negatives. Let's run this, make sure that this works. And this is going to be a feasible solution, but there's definitely a faster way to do it. While this is running, let's see if there's faster ways to do this. So it is non-increasing order, both row-wise and column-wise. What does that mean? It means that in a row, at least, you can be sure that it's always in a descending order. So if we stumble in a row, if grid I, j, if it is less than 0, then we know that the rest of the, so we can do this. M n is equal to len grid 0 m n n. This is going to be m n, sorry, this is going to be m. And what we're really doing here now is, if we stumble upon a negative number, we could say that negatives plus equals, and where is our j? J is what we care about. It's going to be m minus j. Does that work? So the length, and let's say that we stumble on the first element, which is a negative number. That means that we have how many elements in the array? M minus j, being the negative, minus 1. Let's see, this works. Oh, and then we also have to break immediately. Break out of this loop. Output 4 expected. Why do we? So does this break? So I should be getting out of this for loop immediately, right? Let's check. There's probably something, some fine tuning that's needed. am I feeling? Let's talk through this first. We're looking at the first element of the array, 4, 3, 2, 1. J is initially at 0, then it's at 1, then it's at 2, and then it's at 3. In the case where J is a 3, and the length of the array is 4, we would say M, which is the length of this. M is supposed to be the length. So these are messed up. N, M. Those were messed up. And additionally, M minus J doesn't have to be minus 1. Okay, so this is a bit faster, and I hope that it makes sense what I'm doing here. Okay, where else can we improve on this? Can we say that if they're also non-increasing row-wise, then can we always not worry about these J's down the road? Potentially, right? So -1, -1, -2. 2, 1, -1. Okay. I got that we're able to now not keep track of sorry. I'm thinking that once we encounter a element in an internal array, in the nested array, that is a negative, the subsequent encounters of the same index of the element where we encountered the negative is guaranteed to be negative or smaller. It's guaranteed to be negative and smaller. So how can we keep track of this J cutoff, essentially? So cutoff, let's call it 0 first. And once we encounter let's see this. If cutoff, if J is equal to, let's call cutoff actually M. If J is equal to cutoff, then I would say negatives plus equals M minus cutoff and break, right? When do we set a cutoff? We would set a cutoff upon encountering a negative value. So if grid ij is smaller than 0, then we say cutoff is equal to j. What does this let us do? We sort of say that cutoff is now equal to j, and also make sure that on subsequent runs we're going to escape from this inner nested array faster. But also this lets us do this in between elements of the array, right? Because cutoff is consistently getting smaller and smaller and smaller. Let's see if this works. Let's see if this is faster. It should be, because we're encountering, yeah, significantly faster. And let's see, how should I explain what we're doing here? Maybe copying and pasting this guy here would help. Okay. Let's say that we're iterating over the first nested array right here. Once we encounter the first negative number, we set cut off to be equal that index. This index is 3. And if we set a cutoff to a specific number, then in the next if statement, we escape from this sub-nested array faster. On the next attempt, on the next nested array, we also do the same thing, checking if each value is negative. However, we have this cutoff that we've previously memorized to be 3. And if this is a negative number, wait, this wouldn't increase the speed of our code at all, because we're still iterating through the consecutive nested arrays and making sure that we are hitting a negative number. So this actually doesn't make us significantly faster. No, this is this is complicated. How would I decrease the amount of things that I have to worry about? Is there no way of, for example, encountering this and then immediately removing these from my array that I have to look at? Well, even if I do remove them, I still have to check that my next nested arrays are negative. It's only in the case where the whole array is negative do I get to completely add the rest of my numbers in there. So, okay, how about we add that and just call that a day. So if j is smaller than 0, then we would negatives plus minus m minus j and break. However, let's include another if condition here. If j is equal to 0 and j is less than 1, then I would say negatives plus equals n minus I, n minus I plus times m. And this would be in the case where, for example, these couple ones are also negative, and once I've already encountered a negative, I know that the rest are negative. So 0, 1, 2, 3, and 3, 4, 5. So it would be, what is 0, 1, 2, 3, 5? What is 5 minus 3? 2. But I need this to be plus 1. Let's see if this works. Oh, and of course I have to return negatives right away. Let's see, I minus n. Sorry, n minus I. It's going to be 1. I don't have to add. Times m. Return negatives. Why am I getting from output to 3? Was this wrong? If j is smaller than 0, I'm going to add two negatives, m minus j, and then break. This should work. What am I doing wrong? Negatives is set for I in range n, for j in range m, if j grid let's num grid I j, and I care about num, not j. If j is equal to this num, there we go. And this should be faster, at least for the very big, for the very big numbers. And it doesn't seem like it's much faster. Let's quickly just check if there's quicker solutions. And no, this is the same approach. This is 1-to-1 to what we had. Okay, so in that case, unless there are no huge input values, maybe with a bunch of negatives, fully negative rows, then our solution here is pretty good. This one, the quick and easy one, sorry, not that one, this one, the quick and easy one that doesn't really overcomplicate things. We just iterate through all nested rows, and each one of those nested arrays at some point encounters or doesn't encounter a negative number, at which point we stop iterating over that nested array and append all of that to negatives. And although it doesn't seem to beat the best solutions, the code is the same, so I'm guessing that this is trial and error running. And with that, let's call this a day. Thank you for watching. Feel free to use this solution. Please like and subscribe, and I'll see you in the next run.